The Icom IC-9700. It's a beautiful radio. I absolutely love it. But is it any good as a receiver, particularly on 23 centimeters? There are more and more reports recently of it not working very well on 23 and being swamped by local stations, particularly during contests. So, is it good or not? Well, this video attempts to find out. Okay, so what we have here is a diagram to try and explain what goes on in the receiver and why I'm going to do the testing the way I'm doing. So what we have is the frequency along the x-axis and the amplitude on the y-axis in dBm, and this signal is the signal that the receiver is going into the receiver from the antenna. And what we can do within the receiver is tune to any of these frequencies. So when we tune to the signal, we will receive the signal. It's nice and strong. It's above the receiver noise floor, indicated by this line here. Anything above the noise floor we should be able to hear okay. Everything's great. And now in an ideal radio, as we tune to these other frequencies, there will be nothing, because there's nothing coming in from the antenna. But what can happen is that as the signal gets stronger, there's non-linearities and phase jitter and possibly other effects inside the receiver that cause what I'm calling here artifacts to be generated inside. So they're like false images, if you like, of the signal that's coming in. And if these artifacts are stronger than the noise floor, as we tune the receiver to that frequency, we're going to pick them up. So the testing I'm going to do is to generate a signal, vary the amplitude until I see these artifacts come up out of the noise. And as they come out of the noise, I'm going to deem that that's the limit of the useful range of the radio. This is the signal generator that I'm going to use to generate a signal on the 23 centimeter band. I've chosen a frequency of 1296.25 megahertz. It's in a commonly used area during contests here in the UK. I've also enabled some amplitude modulation. This is just to increase the likelihood that that spurious signals are going to be generated within the receiver, because the signal levels bobbing up and down, any non-linearities in any circuitry will tend to be exaggerated. The AM modulation frequency is set to 1 kilohertz. I've got two settings on this generator, 1 kilohertz or 400 hertz. I've chosen the 1 kilohertz, no particular reason. And the amplitude, you can see there, is set to minus 40 dBm. It's that amplitude that I'm going to adjust during the testing to find the dynamic range of the receiver and the signal level at the point that causes the spurious signals to go above the noise floor of the receiver. So the output of the signal generator is connected directly to the antenna input on the back of the IC-9700. I've then got the 9700 plugged into a computer. It's a Mac computer. It's plugged in via the USB cable, and that creates a virtual audio device on the computer. And using that, I can measure the sound power level that's being picked up by the receiver. So that allows all the measurements. So with a combination of the signal generator adjustment, setting the power level into the radio, measuring the power level coming out of the audio port, it allows us to measure that spurious free dynamic range that we're after for the receiver. So this is the Icom 9700. The antenna input's directly connected to the signal generator. Signal generator's off at the moment, and you can just see the waterfall and just the general noise that's in the receiver at that point. Few settings to look at. So I'm on upper sideband. I've got filter 2 selected. If I look at filter 2, we've got a bandwidth there of 2.4K, and it's starting at 300 going to 2700. Apparently radios are normally compared using a bandwidth of 2.5 kilohertz, but I think this is the standard filter 2 setting on this radio that I'd normally use when contesting, so I'll be using this as my benchmark. Notice that I've also got the internal preamp switched on. That's how I would normally use the radio without a masthead preamp, so I'm going to test it in this configuration. Other settings that can affect the spurious free dynamic range are the AGC and the IP plus function. So Icom say that the IP plus function improves the performance with strong stations nearby, and the AGC, is best to switch it off so that the signal doesn't back down the gain of the receiver when we're trying to measure the sound power levels on the frequencies nearby. I've set the AGC to off, the fast setting I've set to off, so that the default you can see there is 0.3 seconds. I've just gone into the radio's menu, edited that fast setting to switch it off, and I'll use that when I'm doing the sound power measurements. You need to also make sure that you've got no noise reduction enabled or noise blanker enabled. Otherwise that will affect the noise power that you're measuring, and the noise blanker can actually cause the signal to spread over the band as well and lower the receiver performance. So if you're going to reproduce these measurements yourself, make sure that those are disabled, please. So this is the audio monitor software that I'm using, Insight 2 by Isotope, and I've got it set here just so that I can see a spectrogram of the frequencies of the noise. So it's just an FFT of the noise there. Not particularly useful apart from it's just showing me what the response is of the radio, and I can check it's what I expect. So about going up to about 2.7 kilohertz 3 there, which is the low pass filter setting in the radio, and then it's dying off there below 300 hertz, which is the high pass filter setting. That's the bandwidth. So I can see it's all working properly there. The levels is showing the audio level in dBs. It's not in dBms or anything. I'm just going to treat it as dBs. I don't really know what it is because it's a sound card. But it can at least show us a relative level of the noise that's being picked up. And we've got a history window here at the bottom. We can just see where I've been testing there and what's happened. But this is the key thing. It's this window here and these RMS levels that I'm going to be looking at during the testing that we do. So I've now switched the signal generator on. Apologies for the sound. I think the fan on the signal generator is quite noisy and it's probably being picked up on my microphone audio. But you can hear the tone now coming through. It's a sort of a 1 kilohertz plus a few other harmonics tone due to the AM modulation on there. And look at that spectrum. So the span on the spectrum scope set to 500 kilohertz. Basically there's noise over the whole thing. Now this is a very strong signal coming in, but even so that's not great. Okay, so I'm now going to tune off. So we've got the Icom being displayed and the noise measurement, and I'm just going to tune off the center, and we can watch what's happening on that RMS. On the RMS reading on the Insight. So you can see the frequency getting higher and higher as I move away from the carrier. And there it goes. And you can hear the tones tuning in and out. So that's actually the intermodulation product just spreading out away from the carrier. We're now down to sort of minus 26 dBs on the audio. And off we go. I'm going to carry on going down to almost 50 kilohertz away. Still a huge signal. What have we got there? Minus 26, minus 25.6 dBs on the noise meter there. Now, I'm missing one very important thing here. I've got the AGC turned on, and the AGC is going to be, if it's affected by the signal getting in, it's going to be backing down the receiver gain on these frequencies. So I've configured the radio for the AGC. Normally the fast setting is actually set to off. Okay, so the AGC is now completely off. If I tune it back up to 250, lots and lots of distortion. It's going to be serious overload going on there. Let me just turn the radio down. Yeah. Oh, lots of overload. But what we can see here, if I go back out to about 50 kilohertz away again, look at that RMS level now. Minus 17 roughly. Turn the AGC back on. Minus 26, so we've got to keep that AGC off to really understand the importance in the signal. So that is absolutely awful. Let's carry on down. All the way to the bottom of the band that we use is about decimal 1, something like that. We've got minus 21 dBs there. Top of the band, roughly 0.5. What have we got? Minus 27. They're very clearly a big effect there with the signal generator. So there we are, the signal generator is set to minus 100 dBm, and I'm tuned into the signal from that. The AGC is switched off. Check that, yes, it's off. And I'm now going to tune down to 10 kilohertz away from the carrier. Decimal 240. Okay. Right, we now have minus 35.6 dBs being registered on the audio monitor there. So I'm now going to turn the signal generator up until that number on the sound monitor starts to increase, which just as it starts to increase, it means we've got about the same level of interference as the noise floor on the radio. So I'm going to treat that as the lowest discernible level, really. So I'm going to increase the signal generator. There's odd clicks that will take place and jumps in the system because that's as the signal generator changes range. It's got some relays that click. But generally it should be okay. Oh, there's another click. So we're still at minus 35.4. That's minus 87 dBm. Okay, minus 35.5 still. Just starting to move there. Minus 34.9. I think we're just starting to get an effect. Minus 35. Where are we? Minus 76 dBms. Keep going. And where are we? Minus 70 dBm. It's definitely an effect I can see there. Now in practice, to hear an SSB signal, you need a signal to noise ratio of about 6 dBs. So in theory, when you're listening to somebody on SSB, they're going to have to be at least 6 dBs above the noise floor. So I'm just going to carry on until we get to about minus 30 dBs on the noise meter, because this will really be messing up the other station now. Well, minus 29 to be accurate. It's getting a bit fiddly now, definitely. So minus, yeah, about minus 29, minus 30. What's going on there? There we go. Oh, a bit more. Right. That is minus 62 dBm. And we're getting a very significant effect there. I'm now going to turn the AGC back on. Back to medium. The AGC setting hasn't actually affected the level there very much. Still about minus 30. May have improved it slightly, so it's not making a huge difference. I'm going to tune back into the signal. Okay. So we've now got the S meter reading again. Now that the AGC is back on, and that's almost 40 dB over 9. Okay, that's the minus 62 dBm, where we're definitely getting a lot of interference. If I go back to minus 70, about plus 30. Just double check where we were again. 10 dBs lower. Yeah, just about discernible. I think I'm going to call it minus 70 dBm is the point at which interference occurs. Okay. Very difficult to define exactly. So we're looking at 30. 30 over 9 is a signal level at which, if you start receiving stations that strong, it's going to start knocking out your weak stations either side. Which, you know, isn't great. Local stations are very often going to be stronger than 30 over 9. I'm now going to have a look at the effect of the IP plus button, so I'm going to tune 10 kHz away again. Right, so yeah, still got the signal generator set to minus 70 dBm. Function, so we've got IP plus on. Now Icom say that this improves the spurious free dynamic range of the receiver. So we've been testing it in its best case. I'm going to turn it off. Interesting. Actually looks better. Minus 33. Off. Can you believe it? Very strange. Okay. Go back. So I'm just going to check the effect of that IP plus setting over the whole band. We are getting a very small effect, actually 10 kHz away, but less than when the IP plus is on. If I turn the signal generator off, at about minus 37 at the moment. So let me turn the IP plus on again. Minus 35. Okay, so what's going on here is the noise is coming up. So we turn the IP plus on. The background noise level is going up by about 2 dBs. And that's probably why Icom say when you leave it off, you'll hear weak stations better. But turning it on, it's supposed to make it more immune to the, improve the spurious-free dynamic range. So it doesn't seem to be making much difference 10 kHz away. So let's see what happens over the whole band. Right, 150 kilohertz away. Minus 22.5 on the sound level meter. IP plus on. Minus 21-ish. Minus 22. So again, don't think it's making much difference at that level. Really isn't making much difference at all. .300 kilohertz away, and we've got minus 30.5, so it's almost, not having much effect at this level. IP's off. IP plus is on. Minus 29. Can't really see there's much difference. Anyway, the only thing I can conclude with this at the moment is that there is not going to be any noticeable difference whether the IP plus function is on or off in relation to interference from nearby stations at these kind of levels anyway. Turn the AGC back on. I just want to actually see what level we're at the moment. Yeah, it's very high level. We're at nearly plus 60. So, a bit more experimentation to do, I think, to see whether a close station really is affected by that function or not, but at least on 23 centimeters anyway, I'm going to leave my IP plus off. I don't see what the difference is at the moment. So after all that, in summary, I think signals greater than 30 dBs over 9 on the S meter will start causing interference to other stations on other frequencies. How serious this is practically, I'm not sure. I think you're going to come across problems now and again with close stations, particularly when contesting and they're beaming at you. Unfortunately, the IP plus function, it won't help, doesn't appear to help at all, and actually introduces some noise on the receiver, so I'd recommend that this is left off. I have to say, I do still love this radio, but it has shown me that perhaps the receiver isn't as good as I thought it was, and a solution like a transverter and an HF radio might be more appropriate for contesting. But for the time being, for my uses and in my location, I'm going to carry on using the 9700. Thanks very much for watching, and please like and subscribe if you enjoyed the video.